Okay, so let's work through this assignment. So question 1 is just extending or repeating the sort of question you had in the first assignment, which hopefully you have dealt with more effectively this time. So what we need to do before we can differentiate is separate that into 3 different terms rather than a fraction. So the way to do that is to first of all bring up the variables on the denominator and write it as x to the minus a half, so the power of a half because it's a root, minus because it was the denominator that we're now bringing up to make it a product, and then we have 3x to the 4 minus 2x to the 3 over 2 plus 3. Multiply out the bracket and the powers will add, so you end up with 3x to the 4 minus a half, which is 3.5, and 3.5 as a top heavy fraction is 7 over 2, minus 2x, and then we've got 3 over 2 minus a half, which is the same as 1.5 minus a half, which is the power of 1, plus 3x to the minus a half. So that is now something that we are able to differentiate. So we're going to multiply that, so we're going to have 3 times 7 over 2x, and then we're subtracting 1 from the power, so that's 3.5, take away 1 is 2.5, which is 5 over 2, minus 2, power of 0, x to the power of 0, which is 1, minus 3 over 2 x to the minus a half, take away 1 is minus 1.5, which as a top heavy fraction is minus 3 over 2. So just to tidy that up, dy dx will be 21 over 2 x to the 5 over 2 minus 2 minus 3 over 2 x to the minus 3 over 2. And there would be 3 marks for that. There'd be a B mark for the work you do to get it into the point of differentiating. Then there'd be a method mark where I'm looking to be convinced that you know what you're trying to do in your differentiation by dropping the power down and multiply and subtracting 1, and then there'd be an accuracy mark or an answer mark for the final solution. So that one will be marked out of 3. Then we come on to the current A2 mechanics work. So question 2. A particle of mass 3 kilograms moves in a straight line on a rough horizontal surface. The coefficient of friction between the particle and the surface is 6 over 49. Okay, so let's just draw a little diagram here. So we've got a particle, 3 kilos, moving in a straight line on a rough horizontal surface. So if I'm saying that it's got a weight of 3, it will have a normal reaction going that way. I'll take its movement to be in that direction, which means its frictional force will act to oppose that direction, and that is it as far as forces. There's nothing pulling it forward, it's just moving. We know that mu is 6 over 49. So in the x direction, which is the direction of motion, Newton's second law will apply. So if that's the positive direction, which is what we tend to do, but if we want to put that to remind ourselves, we will have minus f equals 3a. So it's negative f because it's acting in the opposite direction equals the mass, which is 3, times the acceleration. There's no acceleration in the y, so the sum of the y components is 0. So r minus 3g equals 0. And we've got friction, so we know that F equals mu r. So those are our 3 equations. We want to find F, and then we want to find A. So to find F, from equation 2, r is 3g, put that in equation 3, and F equals mu, which is 6/49 times 3g. So I've got, need to get back into calculator mode. I've got g stored as a in my calculator. If I want to just check that, if I do shift and recall, it shows me what all the things I've got stored against my variables. So a is 9.8, so I can carry on using that. So I can write 6/49 times 3g, which is a, and that comes to be 3.6 newtons. That is to two significant figures, so I don't have to worry about the rounding. So that's my frictional force, and show that the deceleration of the particle is minus is 1.2. So if I now put that in if I then put that into equation 1, minus 3.6 equals 3a. So a is minus 3.6 over 3, which is minus 1.2 meters a second squared, as required. So it's to show that 1.2 deceleration, we've got a negative acceleration, which means we've got the deceleration. Part B. The distance of the particle at the point, the speed of the particle at the point O is 9 meters per second, and it comes to rest at the point A. Calculate the distance OA. So we have an initial velocity of 9. We have a final velocity of 0. We have an acceleration of minus 1.2. And they want us to find S. So what SUVAT links UVA and S is V squared equals U squared plus 2AS. So write that down, showing whoever's marking this, you're about to do the right thing. 0 equals 9 squared plus 2 times negative 1.2 times S. So 2.4, that's going to be negative, so I'll bring it across to make it positive. 2.4 S equals 81. S equals 81 divided by 2.4 equals 33.75. We need to have that rounded to 2 sig figs because G has been part of calculating the acceleration, which is 34 meters 2SF. Okay, so marks for that. There's 4 marks for part A. And those 4 marks will be an answer mark for finding the frictional force, an answer mark for showing the acceleration, and we would have a mark for each of the 2 resolved equations, whether they're B marks, they're probably M marks actually, and then I've got the 2 A marks after it. So a method mark for resolving correctly Newton's second law, a method mark for resolving correctly the equilibrium forces in the y-plane, an answer mark for each of those 2. So that's how those 4 marks would be distributed. And then for part B, there'd be a method mark for selecting the correct SUVAT, an answer mark for correctly substituting everything in, and then a final accuracy mark for the 34 meters. So we've got 1, 2, 3, 4, 5, 6, 7 marks for question 2. Question 3. A boy sits on his toboggan and rides it down a straight line path on a snow-covered hill. The path may be modelled as a line of greatest slope of a plane inclined at an angle alpha to the horizontal, where sine alpha is 5/13. The coefficient of friction between the toboggan and the slope is 0.2. The combined mass of the boy and the toboggan is 52 kilos. What's its acceleration? So there's my boy and the toboggan. His weight is going to act like that. If that is alpha, so is that, which gives us our resolution for the weight. There'll be a reaction force perpendicular to the plane. This is a kid who's going downhill on his toboggan, which means we're going to have a frictional force opposing that. We know that mu is 0.2, and we know that sine alpha is 5/13. So this is one of the questions where they want you to deal with that as a fraction. So sine is opposite over hypotenuse. So that is going to be, hopefully recognize that as a 5, 12, 13 Pythagorean triple, but if you don't, that's going to be the square root of 13 squared less 5 squared, which is 12. So that means that sine alpha I can replace with 5/13, sorry, and cos alpha would be adjacent over hypotenuse. I can write as 12/13. Right, I am going to set my plus x and plus y to be down and perpendicular to the slope. And way to go. So we're trying to find the magnitude of the acceleration. Fx n2L is going to apply Newton's second law. It's accelerating in the parallel to the plane. So I'm going to have 52g. The horizontal component of weight is the one that flips on an incline. So as you see here, horizontal is opposite the angle. So that would be sine alpha minus F equals the mass times the acceleration. In the y plane, the sum of the y forces equals 0. It's in equilibrium. So we have r minus 52g cos alpha adjacent to the angle equals 0. And we know that f equals mu, which is 0.2 r. Equation 1, equation 2, equation 3. We want to find a, so we need to end up in equation 1. In order to help be able to use that, I need to find f. To find f, I need equation 3, which has got r, which I'm going to get from equation 2. So my route through this now will be from 2, r equals 52g cos alpha. Plonk that into 3, and f will be 0.2 times 52g cos alpha. We can evaluate that now, or we can deal with it further on up the line. Doesn't matter. If we choose to do it now, we're going to have 0.2 times 52g times cos alpha, which is 12 over 13. So that is going to work out on my calculator. 0.2 times 52a times 12 over 13. So 94.08 is the frictional force. I'm not asked for that, so I'm not going to worry about units. I'm not going to round it because I'm going to substitute it into another equation. So plonking that in 1, 52g, sine alpha I know is 5 over 13, minus f, which I've worked out as 94.08 equals 52a. Okay, so 52g times 5 over 13 minus, now that is the most recent answer, so I can just press ans. Will give me what that comes to. So I've got 101.92 equals 52a. So a will be 101.92 divided by 52 equals 1.96, or to two significant figures, that will be 2.0 meters per second, 2 sig fig. Okay, and we've got 6 marks for that question. So there'll be 1 mark for the Newton's second law, 1 mark for the equilibrium in the vertical plane. Then we'll have an accuracy mark or an answer mark for calculating the friction. Then we'll have a method mark for substituting that back in to equation 1 and eliminating f, and an answer mark for your acceleration, and the final answer mark for correctly rounding. So 1, 2, 3, 4, 5, 6. 6 marks for that question. And then finally, question 4. This diagram shows an object A of mass 6 kilograms. Hold on. Lying on a rough horizontal table. The object A is connected by means of a light inextensible string passing over a smooth pulley at the edge of the table to another object B of mass 4 kilograms hanging freely. The coefficient of friction between the object and the table is 0.4. Initially the system is held at rest with the string just taut. Find the magnitude of the acceleration of object A and the tension in the string. Okay, so let's just redraw our little diagram here. And let's put some forces on it. So I'm going to have a tension in the string, which is going to be equal throughout the system. It's a rough horizontal table, so this is going to have a weight of 6G and a reaction force and a friction in that direction. This is going to have a weight of 4G, and this whole system is going to accelerate downwards or it's not going to move. So that's what we are dealing with, and we know that mu is 0.4. So on A, so on particle A, the sum of the x components would be acting under Newton's second law. So we'll have T minus F equals 6A. We'll have the sum of the forces in the y plane coming to 0, and that will be R minus 6G equals 0. And we also have F equals mu, which is 0.4 R. Then on B, we've got Newton's second law acting in the y direction or moving down, so we will have 4G minus T equals 4A, and that's equation 4. And we want to work out A. So to work out A, we're going to be working with equation 1 and equation 4. What we need to do is to get rid of F as a variable in equation 1, and then we can just add the two equations together. So I need to get rid of F. To get rid of F, I need to know R. So from 2, R is 6G. In 3, F equals 0.4 times 6G, which if we keep in terms of G is going to be 2.4G. Put that in 1 and I get T minus 2.4G equals 6A. So if I call that equation 5, now if I add 4 and 5 together, T's are going to cancel. I have 4G minus 2.4G, which is 1.6G, equals 10A. So A will be 1.6G divided by 10. So 1.6A over 10, is 1.568. So rounding that to two significant figures is going to be 1.6 meters per second squared. And then if I put that into equation 5, because we also needed to work out what the tension in the string was. So the tension in the string would be 6A. Remember, don't use the rounded value, use the full value. So 6A plus 2.4G. So multiply that by 6 and then add 2.4. Oops. G. So the tension will be 32.928, which the two significant figures will be 33 newtons. Two significant figures. And then the last part, what assumption did the word light above enable you to make in your solution? The fact that the string is light means that it doesn't affect the mass, which means the acceleration is constant throughout the system. So B, light string means mass doesn't vary as more string moves from one side of pulley to the other, meaning const accel. So the light string means the mass doesn't vary as more string moves from one side of the pulley to the other. So if there was a mass, if that was a heavy string, then it means that as B falls and more, sorry you can't see, so if it was a heavy string, as B falls and more string appears on this side, then it would increase the mass of what's acting downwards, which means the acceleration would change as that mass increases. So you wouldn't have a constant acceleration. So marks for that, 9 marks for part A. So the 9 marks for part A, well, you are going to get an answer mark for that and an answer mark for that. You're going to have a mark for your first equation, a mark for that equation, and a mark for that equation. Then you will have a mark for eliminating F from the first tension equation. So 1, 2, 3, 4, 5, 6. And you will have a mark for then eliminating T, and a mark for then substituting back in. So that's 1, 2, 3, 4, 5, 6, 7, 8. And they want to give you another mark as well. Wow. Well, let's have a method mark for the substitution and an accuracy mark for doing it correctly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then an E mark, an explanation mark for what that assumption actually allows you to do. So 10 marks for that question. So there you go. that is assignment number 2.